My name is Martin Kesserman. I'm with the PSO from VMware, and a number of colleagues in the US and in Germany and myself, we all helped Siemens IT Services and Solution and Services to build a worldwide cloud. My co-presenter is Michael Koller. He's going to start, and then we're going to just interact as we go.
Thank you, Martin. So I'd like to say good morning. Thank you for coming. For those of you who aren't aware or don't know who Siemens is, I'd like to give you a little background on who we are, the businesses that we're in, and some of the market segments that we serve. Siemens is a global conglomerate. We focus on three core sectors. Industry, which is our heavy machinery, automation, and building lighting solutions. Energy, the business of power generation and distribution. Healthcare, which are medical solutions. And then there's the cross-sector activities or the cross-sector businesses, which are really the horizontal services across the Siemens units that deliver services to Siemens and the Siemens customers in those business segments or those verticals. There's Siemens IT Solutions and Services and SFS, Siemens Financial Services. Interesting thing about Siemens, we are a global company. We operate in roughly about 192 countries around the world. We have upwards of 350,000 employees and have about 180 million euros in revenue. And the interesting thing about that is it means that we have a lot of very complex solutions. We have a lot of varied global requirements that we need to support and a lot of complexity in the business models that we have to deliver IT solutions to. So what does Siemens IT Solutions and Services do at a high level? We really are a global IT provider that leverages the vertical expertise of Siemens to our customers to develop world-class IT solutions and services. An example of the solutions that we provide are consulting, outsourcing, application consulting, shared services, and the like. We build private clouds for our customers, hybrid clouds, cloud integration. And from an overall revenue perspective, we're about 4.7 billion euros, and we have roughly 35,000 employees across 40 countries delivering those services today. So what I'm going to talk a little bit about is, given the complexity and the different types of businesses that Siemens has and that Siemens IT Solutions has to support, is the concept of what we call a global delivery capability. And that global delivery capability, what you see on the screen in front of you, is really the locations around the world today that Siemens provides different services to our customers through. They range from our service desk all the way through different types of professional services. And our global delivery concept really was to take what are disparate services around the world that really have disparate ways of delivering them, not uniform processes or technologies, and create a standardized global footprint of how we deliver those services. It's kind of the first premise to it. The second premise is we didn't want to build a single model for every type of service in the world. We didn't believe that would be cost effective. So what we looked at was a tiered service model based on our global need of how we operate in different countries and the units that we have to serve from a Siemens perspective to deliver the right cost for that service. And those are things from managed server, managed desktop, all of the different elements to provide an IT solution. Last part is, if you look at this global footprint that we have, is to find the right location to deliver that service. So we have the concept of competency centers around the world, which allows us to leverage the best and brightest of our technical capability to deliver the solution anywhere in the world where it makes sense or that it's required, which allows us to deliver that service effectively and efficiently. And then lastly, because we operate in 190 countries around the world, to deliver those services locally, but also allow for customizations based on in-country laws. So for example, like in China, you can't take data out. You have some issues in Italy as well. That allows us to customize those solutions, either for country requirements and regulatory issues, or individual contract needs for our customers. So if we look at that in total, that's really kind of the concept we have from a global delivery perspective, okay? And what we set out to do in building our cloud. So why virtualize and why standardize? A lot of this is what I would say is motherhood and apple pie. But I think from my perspective, we could always focus on the cost. which is one of the compelling reasons why back in 2004 a lot of us started to go down the road and virtualize our infrastructures. But I think as we look at the business and where the markets are going and how things have to be adapted to change, I think we look at a different set of business and operational needs that seem to be coming ahead of cost at times. I think flexibility and the ability to adapt to meet those changing requirements, whether they be regulatory or they be customer, is paramount now. I think a way to integrate the end-to-end environment, if you think about being a global company and you look at all of the different facets of desktop, servers, applications, and infrastructure, all need to be brought together and managed centrally and understand the impact of each other in that environment and the services required to support them. And then I think lastly, the time to provision. I know when I first started at Siemens about 6 years ago, it took us a pretty long time to get infrastructure on the floor for the business units to take advantage of and to meet their need. Over the last 3 years that we've been on this journey to build clouds and virtualize our data centers and our applications, we've now gotten to a place that on average could be about 3.5 to 4 months to put that gear in. We now can do it in about 3 days. And 3 days includes all of the approvals, the security scans, and everything else that we have to go through to make that virtual machine available for the application community or an end user if that service is already provisioned. Okay? So that's kind of the operational needs, at least from my perspective, that drove a lot of what we looked at in building our global requirements. From a technology perspective, I'll pick on 3 main ones. No common platform for virtualization. I don't know how many of you in the room are global companies or have lots of lines of business. At any given time, we've got people in our company that have been focused on every hypervisor under the sun, whether it be on x86 or it be on risk-based. So we wanted to get to a place that said for our base services, commodity type services and some of our non-commodity services, a common platform, and that platform means DR, backup, recovery, monitoring and management, provisioning on the floor. And that was key because we believe by having an integrated platform, it would meet some of the other objectives we were talking about, the business needs. So that's first. Second, a global approach for the implementation of virtualization or related services. Right? That gets into not only virtualizing your box, but it gets into how I get there. Because the whole process of transforming my environment and going from what is a physical machine today to a virtual, the first step is just consolidating it, putting it up, and taking advantage of your asset. The next one is, how do I transform that and take advantage of automation and different tools to get real agility out of my infrastructure? And then I think lastly, I look at a global management process based on virtualization. The process of managing virtual capacity, provisioning it, is very different than the way you would have done it in a physical world. So we looked at how do we do that, but also knowing we have invested in the previous screen, which was a global delivery concept that we have NOCs and infrastructure around the world. How do we integrate those management processes into the physical ones that we have to support? Because beyond the x86 world and the cloud that we built there, we still have roughly about 3,300 Unix servers globally that interact with that architecture or that infrastructure. So we need to bring them together. So those are the types of things when we think about virtualization from a business impact to Siemens, and then as a propeller head like me, the technology impact it has to make things better for our technicians and the people delivering those services. So we have a target architecture at Siemens, and the project that we started with was something called Project Stormfront. And really what Project Stormfront was, it really was for us to sit down and think about to do something transformational with how we deliver our services and how we would use virtualization to achieve the outcome we wanted to get to. And we looked at it, one, for the internal services that we provide to Siemens unit, and then second, to our external customers in the market. A big element to that, one of the things that we spent a lot of time with over the years was actually being a systems integrator. If you look at the chart that I presented earlier about the diversity of Siemens, the size of what we support, and the different types of infrastructure, we spent a great deal of our time putting together various building blocks over and over again to meet the need that Siemens has. Well, one of the things we said we would do going forward, since this was kind of a green field, was look at what were the best technology products out there in the market at the time, going back 3 years ago when we started this journey, and put together a framework. First, a framework that allowed us to plug and play components as they evolve in the market, pick new ones if required, but also key infrastructure components or building blocks that we wouldn't have to integrate time and time again. So we got to an approach with the components that we picked, where they would essentially become a SKU that we could deliver to anywhere in the world as services were required. As part of that process, we looked at the infrastructure, our data centers. We really wanted to come up with a way to change our data center footprint as well as the servers and infrastructure that we manage. So we looked at, how do I understand what's in my data centers? Because that's really the first road or the first step to understanding the transformation we had ahead of us. So we looked at, as part of that infrastructure and tools framework, to pick some leading edge tools, particularly HP's DDM, to go out and what we would call fingerprint our data centers, our applications, and the services that they support. And that process allowed me to essentially understand the applications, how they talk to each other, their dependencies on the infrastructure, what they talk to, and so on. So that was part of our approach to infrastructure optimization. We looked at everything in total. From a server perspective and a server consolidation perspective, we wanted to look at what was the best way to do that, the best types of services. And we could probably support one of everything in this model, which is what we've done in the past. But we looked at picking 3 fundamental building blocks for the server infrastructure that we had, based on blade technology. And if you go back 3 years ago, blade technology really didn't have enough memory for some of the larger applications and databases we wanted to virtualize. So within the architecture, we kept what would be a blade element and a rack mount. And we had 2 types of blades, 2 types of rack mounts to support the various workloads that we had in the environment that we would need as we virtualized them. And those became our standard. And there's a reason why picking standard building blocks is important. If you think about monitoring and management and NOCs and so on, once I get to a place where I understand the standard sets of incidents in my environment, I'm now able to filter them out, I'm able to automate them, and I'm able to get a lot more flexibility out of the environment. We looked at redoing the service catalog, and that's actually a very difficult process at times to go to an end user that is used to saying, I want to buy a box, it's got 64 gig of memory, it's an 8-way, it does this, it does that, and say, well, hold on. We're now going to provide you what we call a t-shirt size. Small, medium, large, extra large, here's the number of CPUs, here's the way it's spec'd to work, and for us, we're a big SAP shop, so we use SAPs to help develop what the t-shirt sizes were. And now you can request a t-shirt size. And here's the standard memory that goes with it. We believe it would meet the SAP's requirement for your application. And here's the services that come with it. And you could go into the portal and then select additional services. But beyond those t-shirt sizes, you'd have to select an uplift if you wanted more memory, dedicated DR, dedicated box. You'd still get a virtual machine, have a dedicated box, because then I still keep to my tools and the infrastructure program that we're working on. So that service catalog became one of the key elements that we use to transform the thinking that users have about the requirement. And I'll tell you, 3 years ago, it wasn't as easy just to say you got a t-shirt size. One of the things we did with some of our early users is we gave them the virtual equivalent of the physical that they asked for, and we monitored it with them, and we watched that application for the first 60 to 90 days and said, you're only using about 30% of what you really asked for. And what we would do is we'd go back in now and turn down how much memory, how much CPU that they had so that it was right-sized for the workload that they were trying to run. And I think that's one of the things when we talk about an optimized operational model is really taking the core ITIL disciplines and looking at how do I, in an ongoing world, optimize what we've already deployed. Because I think one of the things that virtualization is great is putting out thousands of virtual machines, which we've done, but then there's the process of optimizing them. Because part of the benefit of it is driving greater leverage with the hardware and software and other assets that you have. And we really need to, we put in a plan to allow us to go back and retroactively look at how do we right-size those workloads going forward so we keep to the utilization, consolidation, and density numbers that we'd had originally envisioned for the application or for the platform. Next bullet point is around a converged platform. I'm a great believer in trying not to do the same thing twice, whether it be testing, remediation, or things like that. So when we thought about building our platform, Siemens has a part of our business and IT solutions services that is a managed desktop. It's an outsourcing function for the desktop. And we thought about, well, we know at some point we're going to want to virtualize our desktops. And what would it take to build a single platform that would manage workloads in the data center for server-based compute and also be able to serve up virtual desktops? Because in my mind, I really look at a desktop in its simplest form as another workload to be run someplace. So we thought about I/O, and we did some other things into the platform a couple years ago with Nexus, about 3 years ago, before a lot of people had adopted it, that gave us greater I/O capability, some more flexibility and things like that that we'll talk about a little later. And we created them on the same platform, which gives me common tools, process, service catalog across the continuum of services. And I think the last one that Martin brought up is a global community of technologists working together. There's other folks from Siemens in the room, Uli Huntsmeyer, that I worked with going back a couple years ago. We all sat in a room in Munich and said, how do we do this for the company? And I think that's the one thing, by having the standards and the collaboration that we've gotten, it helped us build a true global solution that meets all of our needs as a company. And I think that's the one thing I take away as a real lessons learned, is try to work together and not build competing architectures or things like that, because it accelerates time to market acceptance and value. At a high level, Stormfront, as we call it, as an architecture, we treat it like a product. So on the screen, you see what is V.1. We're already working on what's V.2, V.1.5 has been deployed. That's how we support virtual desktops. These were the key elements that we deployed when we went live over 2 years ago. And they're base elements in the architecture. With one noted exception, we added vCloud Director about 7 months ago with some of the work efforts that we have out of Munich to deliver those capabilities globally. The one thing that I'd also like to point out, if you look at the screenshot that's on the right, and it's probably not very legible, what that is, it's an ad slick for our Beijing data center. And our Beijing data center is using the exact same sets of tools that we have listed here to deliver the same types of services in China. So we've really gotten good at the standardization element of making this work. And if you're going to do a global cloud, that standardization is critical. And it's not just VMware, it's the other elements of the architecture of server storage and network to make that work, okay? So we'll talk a little bit about global design and delivery. One of the things that I thought I'd put up on the screen was kind of our implementation roadmap. And you can see we started back in 2008. That's actually when we started the transformation in our data centers and for our internal customers. The engineering effort actually started in 2007. And in 2007, we sat around with VMware, NetApp, Fujitsu, and some of our other partners, and we thought about what could be, based on where they were at with 3.0 at the time and 3.5 and some of the other technologies that were out there, and thought about building a platform, everything that goes in, backup recovery, the whole 9 yards. And I think that's something to think about from a cloud, is right, you need that end-to-end, you need all of those same services to run that infrastructure if you're going to put it someplace else. And we spent, the better part of a year proving out the concepts with NetApp, Fujitsu, Cisco, and VMware to prove that we could build a platform that would scale to support the volume that Siemens needed. At the end of 2007, we pretty much proved it out with a lot of help from our vendor partners. And I'll say that's something critical to think about. We actively engaged all of our partners as part of our planning processes, our architecture processes, and on into what I would say is operational readiness. When we took it out of the dev world and decided to productionalize it, we actually have residents still today from each one of our partners on site working with us as we roll this out, because we continue to add new features and functions quarterly to the technology platform. And that knowledge is critical that our partners have of what they're building and how that affects our roadmap. So come to 2008, where we started, I think about our data center transformation. 11 Siemens locations we started with from a North American perspective, reduced to 2. Roughly 15,000 servers in scope for what we started. And this is just x86. This doesn't even touch the Unix infrastructure that we run. And roughly about 9,000 applications sit across that landscape. What we did for the first part of the implementation was we implemented our core platform, which for us is server storage and network, essentially. Moving into 2009, we looked at the operational management, which is the integration to all of our production monitoring tools. So we leverage products like HP, Tivoli, and things like that globally. So what we worked on in 2008 was the integration into those tools so that our real-time events and infrastructures flow to the same infrastructure that our physical servers go and take advantage of our NOCs globally. So we built the work breakdown instructions, troubleshooting, all of those types of tasks required. I'll talk about this in a little bit, but we talk about a concept called management and compute cores. And I'll talk a little bit about why we did that and the relevancy of that from a cloud model. But 2009 was essentially the platform end-to-end. Beginning of 2009 into 2010, we standardized our service catalog, and we have Martin's going to walk through and talk about some of the things that we've done on global orchestration, the catalog, what the screenshots look like, essentially the market basket approach to buying a virtual server at Siemens. We've essentially been working through in 2010 a global alignment around our operational readiness so that everybody does the exact same task the same way. Even with the platform being rolled out and running in different data centers, we still have a little bit of training to do. That's the hard part, is getting everybody on the same page to get them to use the processes and technologies the same way. And we've gotten to what would be a utility-based cost price model. So now we look at a consumption metric of how you get the services, those t-shirts that we talked about, how much storage you use. We talk about managed backup, right? So we look at different types of metrics now to take care of the environment. The last part that we've been working on actively with VMware and other partners is pushing this to the cloud, so that you have a portal that you can go to and request the services at will. Today, there's 3 services that are critical that we've moved to this model. 1, requesting a server is cloud-based. 2, desktop, a virtual desktop. And 3rd, which is one that's kind of unique, you can actually migrate your application via the cloud. So we spent a great deal of time. We talked about automating the application migration process. We worked with PlateSpin, Novell, and others that allow you to go in, essentially answer a pretty lengthy 14-page questionnaire about the app. It kicks off some discovery tools in the background. And what it will provide back is an application profile based on what we discovered in the environment with the tools that we use to say, is this what you want to migrate? If it is, it allows you to select the appropriate drop-down for the workload and the sizing of your box. And then within a couple hours, about 3 or 4 if there's no data migration is a different issue, you have your new virtual and your new application hosted on our cloud or our infrastructure as a service platform. And that's something we've been rolling out little by little within North America to the Siemens units here. So what I'm going to do is let Martin talk for a little bit, and he's going to talk a little about our service orchestration engine and what we've put together to facilitate kind of the global movement and management of our workloads.
Thank you very much. Once we've had the virtual infrastructure set up, as Michael said, that has been done locally in the different operation centers worldwide, we had to combine them. What we did was setting up all the operational readiness, the processes that Michael was talking about, that they're equal for each data center, that they will be done the same way. In addition to that, we had to do all the service orchestration. We had to make sure that our international customers would be able to order virtual machines or order services all around the world to be hosted in Siemens IT Solutions Services data centers the same way. To be able to do that, we had to come up with a worldwide capacity management in an environment that is locally managed and locally operated. We had to get all the information about those environments together and manage on a worldwide level. At the same time, we had to make sure that those T-shirts, those virtual machines, or those V-apps could be ordered all over the world. So if a customer in Finland, for instance, orders a virtual machine to be placed in the US, that worked and that will be hosted in the US and will be run in the US and charged to the customer sitting in Finland, for instance. To do that, we had to come up with a ordering portal that is usable in each Siemens entity, and that is to build to Siemens standards. Wrong side.
Hey, Martin, before we go there, can we go back for 1 second? There's
Sure.
one point that I really wanted to talk about. So on the slide, it talks about automate business IT service transactions. That's really important because one of the things we tried to do that we heard lots of complaints from our end users, customers, and things like that is it's so damn difficult to get a server from you guys. Everything is difficult. I'm tired of talking to IT. So one of the things we've tried to do with the service orchestration engine is really to put the workflows in to tailor it to how the user wants to deal with us, whether it be LOB or customer. And we're able to put those workflows in, those approvals in. We integrate it to SAP for financial information, things like that. And what that also helps do is it drives acceptance and use of the platform. So now it's not dragging them along. I'm like, okay, tell me how you want to do it. We'll create this process, we'll automate it, and we'll allow it to be adapted to your need. And we'll also, by the way, because we're doing the processes the way you would like, we're going to report on it that way. So we can give you the metrics that's relevant to your business and what you're trying to do versus the way we think about it, right? Server, storage, network, IOs, megabits per second, throughput. They don't really care. They want to know how many orders and things they can do. So that's one of the other key elements between the service orchestration that I think is key, that it gives us that flexibility to adapt to the lines of business and customers we have to support.
Thanks. Keep pressing the wrong button. Okay, the service orchestration, this slide is in particular for the virtual server. The virtual server is just one of the many service offerings that one can order within Siemens. You could order a phone, you could order a desktop, a virtual desktop, or whatever. The virtual server as such was the main topic that we actually looked at. Because it's global, we had to make sure it also can be ordered globally and it can be delivered globally. And it had, as I already said, it had to fit into the standard order process, which is a portal-based ordering. And as you can see, I'm coming down, it's a bit easier. Up here, the user would request a virtual server based on the service catalog, based on the T-shirt sizes. Could even be a vApp, which is a bunch of different virtual servers that would be ordered at once. Could be a software as a service. And then it would run through the business process in terms of that it had to make sure that the customer existed within the database, and so we could actually order it, etc. And at some stage, it would actually drop down to the virtual server, where using web services, we would then initiate the process in the orchestrator, in the VMware orchestrator, to actually go and provision that server automatically based on all the input, the information that has been gathered by the customer and has been aggregated through the CMDB and the information we already have about where it's going to be placed, what resources it's going to be used, what SLA it's going to use, etc. And once it had been created and handed over to the customer, it would then update the CMDB automatically, go back up into the business process, and make sure that at the end we could actually also bill the customer. That's running fully automated at the moment, and we're really happy about it. So some of the information that actually needs to be gathered or needs to be used is listed here. We not only have to set it up, we also have to be able to modify it if the customer needs to have more RAM, needs to have more disk, or actually wants to get rid of it and delete it. At the same time, for internal reporting, we also have to be able to provide data from the virtualized environment up to the other application and services that need to be able to process them and report on them or bill on them or do capacity management on them. And that's all been integrated in the service portal, in the Siemens service portal, where this is just a screenshot of the web page with all the possibilities that a particular customer has when he logs in. So it's self-service based, so a customer ordering a vApp or a virtual server cannot do anything wrong, because that's sort of the process that he goes through. Is those 5 steps, where he first has to tell about himself, who he is and what he wants to, and then select from the T-shirt sizes or the service catalog. Could also be software as a service, for instance. We've also set up an environment for developers where they can order their own developing environment, which is based on Spring Source technology, and will actually create 5 different virtual machines for the developer to use and hand back again after testing or after finishing the development. Once the information has been entered, it's also about storage and backup that has to be added to. Here, this SLA based, so whenever what he wants and what he wants to pay for. In step 4, a customer then adds the information that he needs to be able to administer its own service, if that's the case. Doesn't need to be, could be full packaged and full managed by Siemens IT Solutions Services, but there's also always customers that want to manage their operation system themselves. That's where they would have to put in the information about who's going to be the admin and who's going to do what. And finally, through the ordering summary, it's then automatically provisioned afterwards.
It's
That's an in-house portal based on some standard.
So we have a couple of different portals running around the world. We predominantly use one in North America, one in Germany. We're going through the process right now of reconciling the fact that we have multiple portals. So we have some commercial ones that we've purchased over the years, as well as some homegrown ones. So actually that screen is a combination of both, because we do use the front end as a commercial, one that we've purchased commercially to deal with customers, and then the integration with it is the portlets that you see on the bottom that integrate to our own proprietary type framework and stuff that we've built. The one other element that I'll cover that's important about how to do this. So the integration that we've done and able to achieve these types of automation and orchestrations is because of the work that we've done integrating with Virtual Center APIs. So that allows us to use templates, right? So if I templatize the way I deploy these match to my t-shirt sizes. Those t-shirt sizes have certain attributes in them. Those are the attributes in my template. And because we suck them in essentially through Virtual Center, through a common API into our portal, into our catalog, that allows us the flexibility to do this with the users. Today, we have standardized t-shirts and stuff. The future for cloud will be, once we've defined a various set of templates for infrastructure, beyond that, would allow you to go in and select the different attributes you want to dynamically build your own t-shirt size. That's when we get to a true consumption model. And right now, some of the software we need to do that isn't yet available, but we're working with some of our partners to get there. So then you'd have truly a dynamic t-shirt size that can be created on the fly. Okay? Talk a little bit about the architecture again, show you a couple of pictures of it and what we did. So it's vSphere based, that's why we're here. I've been coming here since 2004, and it's nice to see more and more people coming. We took an approach to building pods, right? And for us, a pod is a block of compute. And the reason we built pods was we talked about earlier the different locations around the world that Siemens operates in and our customers, and we needed to get to a configurable building block that we could deploy quickly and make it repeatable. So we picked 3 types of pod architectures. A D pod, which is our data center pod, and the data center pod has 2 flavors, a scale up and a massive scale out. And the scale out is what we run for our mission critical enterprise workloads. That's kind of our tier 1 blade infrastructure, 459's availability, all of those types of things. Our R pod is a remote pod. They go to smaller compute locations, smaller data centers. They have all of the same tool sets that we saw in that first slide that I showed around the V.10 architecture, and it's also the same tools that we have in the data center. But it's put it out in the field so that we can provide those services locally. And those are required for things like hosted VDI, applications that have latency issues that can't be moved to the data center, as well as we use it as a migration platform. So right now we're working in Orlando, Florida with one of the Siemens units, specifically Energy, and we're migrating their data center from Orlando to Chicago. And we have what we call an EPV, endpoint virtualization. It's equivalent for all the stuff you're looking at today. You hear about vBlocks and all that stuff. That's essentially what it is. It's down in Orlando, and the processes we talked about doing P2V with PlateSpin and other things, we're taking all of those servers and workloads and putting them on that box. And then when we're done, we'll fail it over using some of the DR capabilities embedded in the platform and migrate them to the GLSDC or our Chicago data center. The vPod is a virtual pod. And if you think about 40, 50 person offices, it doesn't make sense to put giant infrastructure in those places. So what you'll wind up doing is putting in larger rack mounts with some local storage and essentially putting in the same virtual infrastructure in a virtual format. So the backup and recovery tools that we use and everything else run in a virtual machine today. In the slide previously, we talked about Avamar. Avamar has a virtual machine. It allows me to put that on a rack mount someplace in a small office, back up their data, ship it to my data center, and then ensure the integrity of their data and back up an infrastructure. Next concept that's kind of important to think about building a cloud and building really lots of distributed services was we took what we call a power plant design concept to building the architecture. And what that means is we separated the management tools from the compute capacity. And the management tools are the same tools we'll use everywhere in the world to run our workloads. The compute capacity is the engine or the CPUs and memory that we're going to use to put virtual machines on. And what that means is I can plug them in at will, kind of an apartment complex, and just keep adding. What it also allows me to do is to look at innovations at different server technologies for compute that I may want to take advantage of from, like when we started with Fujitsu Siemens. Today we've now tested and certified HP and IBM as compute engines as well. vBlock could be another compute engine we use. So it gives me the flexibility to just keep adding capacity that way and then focus on my management core and not have to worry about what vendors, what our technology partners do with those boxes and how it affects how I operate my infrastructure. Another key element to why we took the pods is their centralized and decentralized management in the way that we use them. So we can drop a pod someplace, connect it back to the data center, and manage it centrally, but also provide local services if needed that may not be required in a data center. For example, file and print, file services, large file systems, things like that, CAD and CAD infrastructure. One of the things we did with that architecture, making it secure and some of the other elements, was we always believed it could reside in a Siemens prem or a customer prem. And that was for two reasons. Siemens is a very large global conglomerate. We grow through acquisition and divestiture. So I have to have an ability to pick up and move and drop stuff quickly. Having an architecture that can be picked up, moved, and sliced off and dropped someplace gives us the flexibility we need to acquire and divest companies and also move companies in quickly. Scale up, scale out, we talked a little bit about that. Really, that's our goal, to keep growing our workloads in our data centers. Automated resource management and usage models. We're a big proponent of DRS and letting the system run itself based on workloads. That's the value. If you look at utilizing those tools and a lot of the automation that's out there, you'll get greater value out of your hardware assets, your infrastructure assets, than you will if you won't. It's very difficult in a virtualized world to figure out what not only are 2,000 virtual machines doing, the 200 hosts, the server, the storage, and the network. That is a very complex task to think about. So we leverage as much of the automation tools we can from the partners that we've built with VMware, NetApp, and others in this model. If you look at the picture on the left, it's some of the components, right? We leverage the Cisco Nexus 1000 switch, vSphere. The FSC BX600 and 900 are our blades. The RX300, RX600 are the rack mounts. One of the things we did early on, we had concerns about I/O. We worked with Fujitsu to put in what's called the Intelligent Blade Panel, which essentially aggregates multiple 1 gig uplinks into the back of the blades, so I can dynamically control and throttle the traffic and pattern in and out of my blades. We did that about 2.5 years ago. We put in Cisco Nexus 5000s and 7000s. They've been in production now for 23 months. Cisco MDS standard. NetApp is our core storage. We do a lot with thin provisioning, dedupe, resource management there. And then from a backup and recovery perspective, we leverage Avamar in our data centers and in our distributed endpoints. Picture on the bottom is really meant to talk to that we're global. We have a global set of processes, a global set of tools, and it's essentially how we deliver our global services through the cloud to our customers. And the different dots represent the different delivery locations where those services are provided out of. Excuse me? NetApp. I mean, both NetApp and Avamar do it, right? So it depends. Yeah, so we use Avamar for the backup and recovery, so we're deduping there because we use Avamar only for OSI backups. And that's where you see a huge reduction through dedupe when you're doing OSI backups with Avamar. We also use dedupe for NetApp for some of the other elements around data, images, and things like that. So it's kind of a two-tiered approach to it. Service management, right? So when we think about it, what Martin was talking about earlier, when we made this transformation now, service delivery becomes process-centric, not tool-centric. So the hardest part about getting technology people to agree to do anything isn't the process, it's the tool. So part of what we've tried to do with the portals and the technologies is create an abstraction layer so we can plug the tools in that make sense based on where we're providing service or where we're going to deliver that service. Integrate it with existing operational process and delivery locations. The one thing that we found is you just can't stop what we're doing and say we're going to do it this way. Right? It's a process to get there, it's a journey. So you have to integrate the old with the new. We tried a couple times just to say, well, we're going to do it this way, and we really weren't able to do that. There's both old and new that you got to carry forward. Within Siemens, we have this concept called Tango. When Martin was walking through the service orchestration, the box that you see in the middle here is our Tango architecture. And that's really our model-driven approach to integration, process flows, business process management, and so on. Think of it as our BPMS platform for technology management and our process management. New services built from the ground up based on virtualization. That is the one thing we did. We looked at a virtualized service and said, we will take advantage of all of those technologies. We will use virtualization in every part of the layer if we can. And then lastly, it's built on industry standards, right? So we use ITIL as our core delivery framework, distributed management framework for how we manage the servers, OVM, web services. And that gives us the flexibility and agility to plug and play components as required, and also integrate what we have while we sunset it and integrate what we need, right? It gives us that path for incremental replacement. A couple of use cases we put in to talk about what we've been able to achieve with it. So from a Siemens perspective, this is our business case for what we've been able to achieve with the transformation, leveraging our technology, and what we've been doing with the platform. This is something that we call shared services. If you ever deal with Siemens, you'll hear shared services, you'll hear something called GAIN. GAIN is our global shared services initiative. We started out with the operating challenges that are on the left, pretty typical to most companies. But I think the benefit, if we look at what comes to Siemens, is really huge cost reduction. Right? We're able to commoditize our global service. We're able to standardize what we do from a KPI reporting and process perspective. We're able to refresh the asset base. And that was key because one of the things we had when we started, we had lots of old applications. They weren't certified. The platforms were out of date. We now have a platform that they sit on that's state-of-the-art, supported by our vendors. We're not out of compliance. We're able to have a lot more flexibility now with what we can do. One of the benefits also to us is from a SIS perspective, right, is we're able to train and transform our operations. And we've trained over 250 people in how to operate the world from a virtual perspective versus a physical perspective. And I will tell you, as our chief architect, and sometimes I get chastised for not bringing people along for the ride. I'm kind of really fast to want to get there. You can't underestimate the organizational change of trying to do these things, right? You can use the carrot or you can use the stick. I've tried both. I'll tell you the stick doesn't work. You have to find what's right for your own organization, but there's a gradual path to move people along. And I think collaboration is the key to get that there. And then when there's a time to put the hammer down, you'll have to. But I think that collaboration and interaction is important. And especially as you move to having virtual desktops, you're going to have the desktop guys fighting with the server guys. That's a lot of fun to watch. Built up capabilities around the world, right? So now globally, in the past we had pockets of expertise, right? So I can pick up the phone, call Uli in Germany. He knows exactly what I'm talking about. We can call up Pinto Dude in Singapore, and he can tell me the exact same thing. So globally, we can all talk to each other in the same language about what we're trying to do. That's key. And then lastly, it's really a platform for growth for us, right? Because of what we've done, the modularization that we've done, it allows us to grow quickly, add new capability, and add it without the existing workloads being jeopardized. This one is kind of one of my favorites. This is where we took the architecture and took it outside of Siemens and took it to a very large disk drive provider in Sunnyvale, California. And we actually used the same technologies. We implemented it in their data centers, and we're migrating them from California down to Raleigh. So they're using the architecture to do that. It's NetApp, which is our standard platform. And we've been working on it over the last 14 months with them. So this is an example of how the cloud can be built, one at Siemens or a private cloud for a customer, leveraging those same technologies to do that. Okay? So from a benefits perspective, what do we see? The technical benefits I'm not going to spend a great deal of time on except for one. The one that I look at really is the integrated life cycle and now a capability to build DR across our applications and infrastructure. I won't say for free. I'd like to say that, but it's not for free. But it's part of the architecture now. With VMware and the way that we've built our cloud model, a lot of the elements that we used to have to handcraft before in kind of a bespoke way now are standardized as part of the infrastructure offering that we built. I think that's huge, right? Because it eliminates the complexity and all the other tools that I've had in my environment. If I think about our platform now, we've got about 38 tools, which really, think about it, isn't a lot. We used to have over 100 in that same space 3 years ago. So that's a pretty significant reduction in a lot of areas: complexity, cost, process, support, and so on. If you look to the right, the business impact, our business case has always been for 17-to-1 server compute reduction. Now there's a great statistic that I have up there. And if someone was presenting to me, I'd go, yeah, right. And the reason I say that is because, and I'm going to caveat it with, workloads vary, right? It's kind of like gas driving your car. We've been able to achieve a 17-to-1 server compute reduction because of the way we've looked at and categorized the applications and workloads that we have in our environment, and we've been able to spread them out to get there. So there's some work that's involved with doing that for everybody. So you may not get that, but you've got to look at your own applications to figure that out. 25 to 33-to-1 server compute reduction is based on Nehalem. That other statistic is pre-Nehalem, so S4. So what we've already seen, just in hardware innovation, we've been able to grow our density. Okay? And we constantly keep adding new infrastructure to the platform just for that reason. Reduction in power and cooling. I'll give you a great example of power and cooling. We have a division, SBT, Siemens Building Technologies. They're in our Chicago data center. They had 162 x86 servers. When we were done, we consolidated them to 8 blades. We turned off all those old servers, all those old storage, and the applications are up and running in their new home. Their CIO, and this was one of the benefits that's not listed here, said, you know what, what'd you guys do? And we're like, well, what do you mean, what did we do? My applications run faster. We're like, well, we didn't change your application. So we were thinking about it, and we're like, you know what? We went back and we looked at the maps, and all of his servers were separated and connected on Ethernet. So when we were done, we put them all on blades. So they're now talking at switch speeds to each other. So just by transforming it onto blades and changing the connectivity without touching any of their apps, they were able to get the performance increase of the newer hardwares and platforms put on the floor. So we're starting to get goodwill and good benefits to our customer as we go through these changes. So those are the type of anecdotal things we've seen along the way that our CIOs in the different units have been happy with. Reduction in space, automation, but I think the one that I look at a lot is the elimination of redundant assets. When I got rid of those 162 servers, it wasn't just the servers, it's the NIC cards, it's the operating systems, and everything else that went with it. And it also, by the way, gave us more flexibility. So those are the types of benefits, right, that we've started to see and are growing faster the more we add to the platform. A few slides back, we talked about there's 15,800 servers that we're transforming. We're about a third of the way through that journey. We've been at it for about 18 months, and we'd like to be done. The one thing that we have found is the businesses are a little leery at times to have you transform all their applications at once, so they want to do pieces and parts. So what we've been taking a different approach is to try and find an ecosystem that you can move in total, test it out, give them the confidence that you can do it, and then get to moving large-scale application transformation for them. Okay? Turn it back over to Martin.
Thanks, Mike. VMware Professional Services helped SIS or Siemens a lot in getting where they are at the moment. Not necessarily because we're the only ones that knew how to do it, but mainly also because we were able to leverage from our consultants that helped Mike in the US and our consultants that helped Uli in Germany, leverage them in getting them together and talk together behind the scenes and make sure that we speak the same language and help on the same level. As I showed you before, the orchestration we did was largely based on the technical side, was largely based on the VMware Orchestrator, where we supported Siemens in defining the processes that were needed to provision the server automatically, as well as the interfaces and the documentation, and finally designing and writing the workflows. In addition to that, education, as it says on here, and reviewing of solution designs, and much more actually. But because we're running a bit short on time, I would like to cut it short here and open for discussions if you have any questions. Yes, please.
Good afternoon, or good morning still. Great presentation. You guys probably know yourself. You guys are probably years ahead of a lot of what everyone else is trying to do out there in the market. So I applaud your efforts and your material in the presentation. It's nice to see from probably a lot of engineers in the field or in this room this afternoon or this morning that you don't have a lot of marketing hype, which is great. I'm still just trying to get my hands around what really the cloud computing is and what your core provisioning tool is there. Earlier slides, you put several different products you're using, but I can't put my finger on kind of exactly what the core provisioning tools you're using. And is it the new VMware Director tool? Is that what you're kind of using for your core provisioning tool?
For the virtual infrastructure, yes. So we have Tango, which is one of our architectures for workflow and automation. So that's an element that manages it. And then tools from VMware underneath the covers. And then there's also some products from Fujitsu for the hardware.
Great, thanks. And as you're referencing private and public clouds, where does, if you just absolutely can't exclude a physical solution for something, how does that tie into the clouds? And are you still including that, or are you just, as long as it's virtual, you're considering cloud? If it's physical, you're not including it in the cloud?
So that's an interesting question, actually. So my own personal view is I believe, at least right now, clouds are virtual in their basis, public clouds. If you think about a private cloud will have physical servers in it, specifically Unix boxes and things like that. Private clouds built by us to run our business have physical assets in it. We have P-Series, Solaris boxes, things like that.
Great. Sorry for all the questions. And probably two more, if I can remember them. One was, you didn't really reference any Windows or Unix, Linux, and proportions to how much you have in your install base.
So Windows, the bulk of it's about 86% Windows. The rest is Linux. We are predominantly a Windows shop in the Windows server space.
Great. And then one other thing is, prior to maybe some of the people not knowing of this, the VMware the vDirector, what other products did you look at or entertain for researching prior to making a decision on this of other vendors that were out there?
For the Director product?
Yeah. If you didn't know about vDirector yet, did you look at, it looks like you're much further along, so if you didn't know about that vDirector product, I was just curious to see if you had entertained other ideas of other vendors that are out there providing that provisioning tool.
We looked at IBM, we looked at BMC, but I think given some of the integration that we required and needed and some of the features that are coming, I think the bet was to continue to go with VMware in our management and automation suite.
Great, thanks.
I just want to clarify one point. Are you storing all your VMs on NetApp via NFS, or do you have a variety of storage for VMs?
NetApp.
It's all NetApp, NFS? Okay, thanks.
Thank you. This is Mohammed. I work for EMC. Just wanted to know what are some of the challenges that you have had during the implementation. Any key challenges that you have had in terms of technical, process-wise?
I had a hard time hearing you.
Right. Any challenges, technical challenges in the implementation in terms of technical challenges or process challenges? Top 3 challenges that you have experienced or had, and how did you overcome them?
So technical challenges early on. I think the hardest part early on wasn't with VMware or NetApp. Actually, we had a lot of issues with the Cisco Nexus gear. So we had technical challenges there. From a technical perspective, I think we had some workarounds or some issues with NetApp and some of the Snap Manager technology, the virtual infrastructure Snap Manager. We had some problems or issues that we had to work through with NetApp on that one. I think that was it from a technological perspective of things that stand out that cause some headaches. From a process perspective, I think operational readiness, just in my own opinion, is a very difficult thing to work through because it's got both a process and a people element to it. And I think that's the hardest part of our transformation has been the people element, getting us all aligned around a common vision and way to do it.
And also in particular to take technology and process apart and treat them differently, because the different operating environments around the world, they don't necessarily use exactly the same tool set, but the processes, they are equal across the different tool sets. So it was quite some task to actually disconnect the processes from the underlying tools and communicate that to all the people involved, that it doesn't matter what management platform it is, the process on a certain level is still going to work the same.
Yeah, I think the other element was that given that we had two different versions of what we tried to build, we sat down a couple of times and tried to reconcile them, and we really didn't get to a place that in my mind, have gotten to a governance structure yet for how we manage the technology, the platform, and some of the changes we want to make as a global company. I think that's the next horizon for us to figure out.
I'm going to stick with the challenges theme. Regulatory compliance, specifically EU data privacy. How'd you deal with that?
Can you say that again?
The EU Data Privacy Act, specifically, it's a huge problem for us today, and I just wondered how you dealt with it. Can
you give me a little bit more than just what, I mean, because the main issue is, I'm not familiar with what you're...
The EU Data Privacy Act basically says that access to a data has to be restricted at country level boundaries, right?
Right, so part of it is you have country data centers, right, from the perspective that we have. That's why we have, the model that's built, there's a GPC, Global Production Center, region, and then country. So you have data stores that are set around the world.
But you've got to pin your data and kind of.
I'd have to understand a little bit more. I'd be honest, I can't answer that question for you.
Okay.
We haven't done that yet.
No, we have.
So right now it's more of a private cloud offering internally for Siemens and how we deliver it. It's not a commercial vehicle that other people could use. So if that's from a commercial perspective to solve that problem, we haven't solved that one yet.
Sorry, great presentation. Early in the presentation you mentioned about profiling the application to understand what kind of server profiles and compute memory disk requirements. What tools do you use? Is it homegrown or is it?
No, we use HP's DDM, and over the years we actually started using it when it was Mercury MAM. So we have all the spiral discovery templates and everything else that do that. Okay. That's the tool we leverage to do that.
Okay, thanks.
Okay. Thank you very much.
Thank you. Thank you, sir.